So many reproductive isolation barriers that are in the environment. So, so if hybrids actually do occur, they have to get through all of these barriers, which I'm about to go through. So, these prevent species from mating with each other, and these are and breaking past these barriers are result in the formation of hybrids, as I mentioned before. Let's get started with pre-zygotic barriers. The first barriers involved in the type of reproductive barriers. So it's when I mean pre-zygotic, I mean that these occur before the zygote is formed within the female. So first, we'll start with habitat. This is the differentiation of the habitats within the same area. So you see this squirrel's in the tree. It's only going to live up in the trees and stuff. That's where it only lives because it's scared of the ground. And then you have ground squirrels, which live on the ground and find their way to live on the ground, but they don't like the trees because they can't climb them. It's kind of weird. But anyways, so they stay on the ground, they stay in the trees. So they inhabit different environments, so they're not going to be able to mate with each other and meet up to actually mate. Next, we have temporal. So what this is that different. Means time. So these difference in breeding periods, meaning different time of day, different time of year, different time of season, or a different time of the months, result in a barrier. So you see this day owl likes to live in the day. It's not nocturnal, so it just does everything in the day, hunts in the day, but it also breeds in the day, and it can't breed with the night owls that only come out at night. So they like to do everything in the night, being nocturnal. And we have behavioral isolation. So this is just courtship rituals that are specific to one species. They only work on one species, so they only get one species turned on. So the courtship dance, you can see this is a blue-footed booby, even though its feet aren't blue. But just pretend it does a dance. So it's just doing this dance here. But this is a different species. You can see by its looks, it's different. So it doesn't actually court another female of another species. Alright? So now we have mechanical isolation. So what this is that morphological differences don't allow successful mating. So as you can see, this is when mating starts to be attempted. So you can see this snail with a spiral shell, and then snail with a polka dot spiral shell. They will try to mate with each other, but this actually would not work because these are different organ structures within each snail. They don't allow mating. Lastly, we have gametic, which is where the sperm of one species cannot fertilize the eggs of another. So this fish will try to externally fertilize these other eggs, but it's not working because they aren't fertilized. Alright, here we have sympatric speciation. Oh snap, wrong thing. We have post-zygotic barrier. So this is actually after the zygote is formed, so when you give rise to new organisms. So let's start with reduced hybrid fertility, meaning that this is when the hybrid actually is born, that it's not be able to be fertile, meaning it's sterile. So if the hybrid develops, it will not be able to produce gametes. So you can see if a donkey and a horse mate, they create a mule, but the mule is sterile and it cannot produce any eggs or babies or anything. So now we have reduced hybrid viability, which is actually occurs before reduced hybrid fertility, where a species cannot correctly hybridize or become a hybrid and cannot develop. So you can see this is the normal species, and then this is the non-normal species. So if it's non-normal, then you see it's different features, meaning it's frail. If it actually hybridizes and develop, it'll be frail, or the species won't develop at all. This is actually a dead salamander. And lastly, we have hybrid breakdown, which is actually if the hybrid is fertile and viable, then actually live a generation. If it actually mates with another population, then it actually cannot the second generation cannot survive. So as you can see, this is the parent generation looking cubs or whatever. So they mate with each other, they create a hybrid, the F1 generation. And then if they mate back with either parent generation, this will not work, and then this F2 generation does not survive. So alright, that's mainly the whole topic. So we went through the whole idea of speciation, allopatric speciation, sympatric speciation, and then the hybrid barriers. So this is all a part of Big Idea 4 and the origin of species and hybrids. So thanks for watching. See you next time.